so we have our mass M1 on a table, our frictionless table. It's connected by a string through a hole in the table to a hanging mass M2. With what speed must M1 rotate in a circle of radius r if M2 is to remain hanging at rest? So the only way to keep M2 hanging at rest if M1 is in a circle, moving. It's inertia. Can keep it moving in a circle. That will provide enough tension in this string to keep this from falling. If this slows down at all, it will slide towards the hole and eventually get stuck on top of the hole. So as we look at this problem, we want to look at the forces on M2. So M2 has a force of tension, and it has the force of gravity. Summing up these forces, force of tension is upwards, force of gravity is mg, so m2g is force of gravity. It's downwards, so minus. That has to equal the mass of this object times its acceleration. But what do we want the acceleration to be? 0. We want to have that mass hanging at rest. So basically, we want the force of tension to equal m2g. Now for mass 1 has a force of tension pulling in towards the center. It has a force of gravity down towards the ground. It has a normal force up towards the ceiling. Which of those forces is actually contributing to the fact that the mass is moving in a circle? Tension. If the string broke, would that mass move in a circle? No. So tension is the is the centripetal force. The force of tension on that mass is the centripetal force. So that equals mass times centripetal acceleration. It's mass m1. Centripetal acceleration, remember, is v squared over r. Well, the force of tension is going to be the same in either case. So force of tension is m2g, which I'm going to put in for force of tension up here. So solving for v will be the square root of m2g times r over m1. Let's see, m2 is 11 kilograms, g is 9.8 meters per second squared, r was 0.3 meters, m1 was 4 kilograms. Plugging that all in, we get 2.8 meters per second. That's how fast it needs to be moving. What if it moved faster? Right, it would start moving in a bigger and bigger circle, so it would pull mass M2 up towards the table. If the speed were any slower, the circle would get smaller and smaller and smaller, and M2 would start to fall.